Get that out of the way. All right, so today is January 9th. And we are talking about arc length and sector area. And again, you have another worksheet. We're starting the year with a bunch of worksheets. Because I don't know, the book, I don't know. I just don't like the book problems. All right. And so, do now. I'm going to give you another minute here to find the area of a circle with a radius of 4 inches. And if you know that, can you figure out the area of a semicircle with a radius of 4 inches? All right. So here we go. What is the formula for area of a circle? Pi r squared. Ladies and gentlemen, my God, you must know these formulas. What is the formula for circumference of a circle? 2 pi r. Very good. Okay. So circumference is 2 times pi times r. Area is pi r squared. You have to know those. I will not give them to you. I hope you know them. You must memorize them. Okay. So to find the area of a circle with a radius of 4 would be pi times 4 squared, which is 16 pi. And it's inches that are being squared. This is an answer left in terms of pi, meaning an exact answer. All right, and that's great. Most of the time we want exact answers in mathematics class because that's the main distinction between math and science, is that science approximates everything and math are too anal for that. Okay, so if you were to approximate it though, in your calculators you can type in 16 pi and you'd see it's 50.27 inches squared, okay? All right, so if you know that the area of a circle, the whole area, is 16 pi square inches, what would the area of the semicircle be? Yes. So for the semicircle, that's just half of a circle, right? So all we have to do is take half of that area, and that would give us 8 pi inches squared. Okay, that's pretty logical, right? Just half of the area because it's a semicircle, right? Okay. So, ladies and gentlemen, congratulations, you just did sector area. So, not that easy, right? But the idea that we have here is that this is some fraction of the area of the circle. And that's the idea that we want to be on board with today, is that if we don't want the complete circle, we want some fraction of the circle. Okay, and we have 2 ways to talk about fractions. But before we do that, we're going to do some really easy stuff. Example 1, rewrite each angle in radians as a multiple of pi, which is really, it's just convert to radians if you want the shorthand, convert to radians. These are the directions right out of your book, but they're very wordy. Convert to radians. And to convert to radians or to convert to degrees, we're going to use our very, very wonderful phrase that says, hey, where's pi? Pi is equal to 180 degrees. And this is our conversion helper. So if I have 30 degrees, then I'm going to multiply by some equivalent fraction. These two things are equivalent. I want radians and I need to cancel degrees. Right now I have degrees on top. I want to cancel the degrees that are on the bottom. I need pi radians on top. How come I can do this? Why is this okay to do, to convert like this? Because we're multiplying by 1. That's exactly right. We're multiplying by something equivalent to 1. It's like multiplying by a fraction 4 over 4 to get a common denominator. That's equivalent to 1. All right, and then we can do some fancy cross reducing. How many times does 30 go into 180? 6 times. 30 goes into 31 times, and 30 goes into 186 times, which gives me 1 times pi, or pi, and 1 times 6 on the bottom, which is 6. So that's pi over 6 radians. Okay, that's great. So 30 degrees is the same as pi over 6 radians. Let's talk about that just for a second and get a picture in our head. So imagine you've got your circle. Where's pi? And if you cut 180 into 6 pieces, how many degrees is that? 30, right? 180 divided by 6 is 30, yeah? Okay. All right, so when you have something like this, I like to think that through and say, hey, converting to degrees is pretty easy. Pi is 180 divided by 6 is 30. Okay. Example 2, rewrite in degree measure or convert to degrees. Convert to degrees. Negative 7/6 pi. I wrote that a little differently because I want to make sure you know that where does the pi go in the fraction? Top. Does it go top and bottom? No. All right. And where does negative go? Top or bottom, right? But yeah, not both. Not top and bottom. That's the key. Okay. So really, we could write this as 7 pi with a negative divided by 6 would be the same statement there. And I need to multiply by my conversion. Is this in radians or is this in degrees? How do you know this is in radians? There's no degree symbol. No degree symbol. Okay, which means we want to convert 2 degrees. We want 180 degrees on top. That's what we want. We want degrees. We're going to get rid of radians. All right, again, we can do some fancy canceling here. Pi on top and pi on bottom reduce. 6 goes into 6 1 time. How many times does 6 go into, 18? 3 with a 0, yeah, 30. 6 goes into 180 30 times. Lovely cross-reducing. And then we can just multiply. Negative 7 times 30 is negative 210 degrees. Nothing, well, just 1's on the bottom. Please make sure, ladies and gentlemen, the degree symbol is important. Make sure that you write the degree symbol when you're using degrees, because test question 11 is, how do you input this into your calculator? And it's A or B, using degree mode or using radian mode. Basically, is it degrees or radians? That's the question. All right, and now you need to know. All right, so let's try this. Example 3. Find the length of the arc. I'm going to call that S. Length of the arc on a circle of radius r, intercepted by central angle theta. Find the length of the arc. Find the length of the arc on a circle of radius r, intercepted by central angle theta. It's a lot of words in here, so we are going to draw a picture. And that's sort of the reason why I'm having you do a worksheet for this, because they drew all the pictures. And that's really helpful, I think. So, find the length of the arc on the circle of radius r, intercepted by central angle theta. Did you guys do this in geometry? No? Raise your hand if you did. A few? Interesting. I used to teach it when I taught geometry, but I don't know what they teach nowadays. I haven't touched geometry in over a decade. All right. So first I want to draw a picture. We have a circle of radius r. So I'm going to draw a little circle, and you don't need a giant circle for this. But just make a small circle on your page, small-ish, a quarter size is probably good. And I know it has a radius of 5 inches. You'll notice I'm sort of drawing this radius as if it were the positive x-axis, standard position. It has a central angle, theta. And in this case, theta is 200 degrees. A central angle is an angle that goes to the center of the circle. And so if I were to open up that angle, is it less than 180 degrees or more than 180 degrees? More, sure. So it's going to go around beyond 180 degrees. And there it is. There's my 200 degree angle. Notice I'm using degree symbol. Okay. Now, so there's my 200 degree angle, my radius of 5 inches, and we want to find the length of the arc that is intercepted by this central angle. Intercepted means if it were to snap it shut, it would eat it. Okay? So if this angle were to snap closed, it would eat all of this arc all the way around here. This is the length of the arc that we want. That's arc length S. S is a measure of what? This is the length going around the circle. What is it a measure of if it went all the way around? Circumference. Yeah? Yeah? Okay. So this S length here, this length around the edge of the circle is a part of circumference. S is a part or a piece of the circumference. More specifically, S is some fraction of circumference. All right. Everything we do in trig is fractions. So this arc length is some fraction of the whole circumference. So tell me about circumference. What is circumference? 2 pi r is circumference. And we need some fraction to figure out that arc length. Well, they gave us degrees. What's our fraction? What's our fraction? We have 200 degrees. 200 out of how many? 360. 200 degrees out of 360 degrees. That is our fraction. 360 degrees would be our total circumference, the whole thing. We have 200 degrees out of the full 360. There's our fraction. So again, I'm going to do some fancy cleanup here. I know our radius. We can plug our radius value in right there. I'm going to do a little bit of reducing of those zeros. So I have S equals right now, 20 over 36 times 2 times pi times our radius of 5. The 2 and the pi and the r are all upstairs in the numerator, just in case you were curious. Can I reduce the 20 and the 36? Yeah, sure. They can divide each by 4. So 20 divided by 4 is 5, and 36 divided by 4 is 9. And so we get, oh, by the way, this is 5 inches. 5 times 2 times pi times 5. What is that? 50 pi. Very good. 50 pi. 5 times 5 is 25. Times 2 is 50. Times the pi. Inches over 9 times 1, which is just 9. This is a great answer and super fabulous. But I think on the worksheet, they might ask you to type it in to your calculator. So we can do 50 pi divided by 9. 17.45 inches. And because I'm meticulous, I'm going to use the approximately 17.45 inches. I personally like 50 pi over 9 because I don't have to use my calculator for that. Please, arc length is length measurements. Feet, inches, miles, yards, length measurements. So they're not squared. All right, same idea here. We have a radius of 2.5 feet. But now our angle, is this radians or degrees? Why is it radians? No degree symbol. That's why, not because there's pi in it, okay, but because there's no degree symbol, all right? Okay, so I'm going to make a small circle with a radius of 2.5 feet. And my angle theta is 7 pi over 4. All right, So first of all, where's pi? 180. So I'm going to go ahead and divide up this little circle so we can get a rough estimate of where it is. How many pieces do I need to divide pi into? 4 pieces. So now I split it into 2 pieces, and I'm going to have each of those. So now I've got 4 on top. I need to do the same on the bottom. How many pieces all the way around? 8 pieces all the way around. So 7 pi over 4 would be counting 1, 2, 3, 4, 5, 6, 7. Almost all the way around. So there is 7 pi over 4. Almost 8 pi over 4, which is almost all the way around. All right, so our intercepted arc, if that angle were to snap back closed, we want to know how long is this arc. It's pretty far. Okay. So once again, it's not the full circle. That arc length S is some fraction of circumference. All right. So now the question is, what's the fraction? Circumference is 2 times pi times r. What is our fraction? Seven-fourths is the angle itself. Out of the total. The part that we have is 7 pi over 4. What is the total circle? 8 pi over 4? You could say that. Or what's 8 pi over 4? 2 pi. 2 pi gets us all the way around. right? So whenever you have a fraction, you have the part over the whole. The whole is 2 pi radians. The whole circle, 2 pi radians. Hey, look at that fancy cleanup. That's kind of interesting. 7 pi over 4 divided by 2 pi. That's our fraction. Times 2 times pi times our radius. Ooh, 2.5. Yuck. Okay. What cancels? Oh, yeah, the 2 pi on top and the 2 pi below. Hey, that's really interesting. S equal, those 2 pi's canceled out. 7 pi over 4 was just our angle theta. 2.5 is just our radius. S equals theta times radius. That's a shortcut. It only works in radians. Okay, but I don't teach it because that's another thing to memorize. I like fractions of circumference. I think it's nice. Okay, so I have 7 pi over 4 times 2.5. What is 7 times 2.5? I don't know. 17. 2. That's kind of ugly. Yeah, 17.5. All right, 17.5 pi over 4. You should never leave a decimal within a fraction. Never, ever. It's just like bad math. So we're going to go ahead and approximate that one. So 17.5 pi divided by 4. So we get 13.74. What is our length of unit here? Feet. Yeah. We'll change that one for next year. All right. Questions on that? Okay. This formula only works in radians. So you can't do that with degrees. Doesn't work. All right. Questions on those? So with that same idea in mind, fraction of circumference, we have the last question. Is this the last question? I hope it's the last question. Oh. No, all right, not quite. Example 4, find the radian measure. No, wait a minute. I don't think we need to do this one. Sweet, let's skip it. Let's do this one. Sorry. I recycled my lesson from last year, but I changed the worksheet, so I don't think you need it. Example 5, find the area of the sector. Find the area. Tell me about area of a circle. Area of a circle is? Pi r squared. Okay, area of a circle, pi r squared. We want area of a sector or a section of the circle as opposed to the whole thing. We just want a portion or a fraction of that area. And so, again, they're giving us a radius r and a central angle theta. So here our radius is 5 centimeters and theta is 240 degrees. And again, I just want to draw a little picture. Our radius is 5 centimeters and 240 degrees. Where does that terminate? 240 degrees. Where does that quadrant does it lie in? Quadrant 3. Yes. Quadrant 3. Okay, so I'm going to draw 240 degrees. It's about there, I think. 240 degrees. And what we want to do is we want to find the area of that sector. So we want to find this whole area. Not the whole circle, but simply a fraction of the area. So that area of a sector is some fraction. What's our fraction? 240 degrees out of 360 degrees. And area is what? Pi r squared. So pi times 5 squared. Pi r squared. So again, I can clean up my fraction a little bit there. The zeros cancel out, divide by 10, top and bottom. And then 24 and 36, we can divide by 6. So 24 divided by 6 is 4. 36 divided by 4 is 9. So that's cool. So that gives me 4 on top times 5 squared. What's 5 squared? 25 times 4? 100 pi over 9. 30, oh, just kidding. Yeah, that's not right, is it? We divided by 6. Oh, so it divides by 12. Oh, silly. Huh. Okay, sorry. It's early. All right. All right. This divides by 12. Let's do that instead. 24 divided by 12 is 2. 36 divided by 12 is 3. Oh, that's better. Okay. 5 squared. 25 times 2 is 50 pi divided by 3. What's our unit? Just centimeters? Squared. Okay, so why? The radius, pi r squared, the radius was 5 centimeters, and I didn't write that in. That's my fault. I should have. It's 5 centimeters, and it's being squared, which means we have square units as well. So this is centimeters squared. All right, area always has square units because they look like little floor tiles, little squares. Okay. All right, letter B, last one. Oh, I've got 3 minutes. Here we go. We have a radius of 3 meters, and theta is 5. Is 5 radians or degrees? Radian. How do you know it's radians? Oh, yeah, no degree symbol. Okay, so ladies and gentlemen, for all the money in the world, not how big is 5 radians? Remember, a radian is the length of a radius wrapped around the circle. So how far would that radius take you? Into which quadrant? Fourth quadrant. Yeah. So you can imagine one radius, this is the pipe cleaner thing we did. Okay, one radius, that's about there, another 3 is about there, another 3 is about there, another 3 is about there, and another 3 is about here. So this is our 5 radian angle measure. All right. And again, we're trying to find this whole area, almost all of it there. So to find that area, we want some fraction times the area. Fraction of area. All right. So ladies and gentlemen, what is our fraction? 5 radians out of how many radians? 6.286-ish. But what's the exact number? 2 pi. Very good. 5 radians out of 2 pi radians times pi times our radius, 3 meters squared. What cancels? The pi on top and the pi on bottom reduce. Good. And what's 3 squared? 9 times 5 is 45 on top with, oh, no more pi. That's good. Over 2 meters squared. And 45 over 2 is exactly 22.5 square meters. Kind of nice. All right, questions on that? Remember, radians can be just a number, right? Because 2 pi is also just a number. 6.28183. Okay. All right, ladies and gentlemen, I'll pass out your worksheet.